Hello everybody and welcome back to Business Guide. Introduction. Tesla has finally settled on a date for its delayed annual shareholder meeting and battery day for investors, September 22nd. The meeting will be held in person at the company's vehicle factory in Fremont, California, though will presumably also be live streamed. Only people who are shareholders of the company's stock can attend. With Tesla Battery Investor Day approaching, it's no secret that Tesla already has a million-mile battery by now. However, while a million-mile battery is impressive, Tesla is currently working on a new battery cell that would be more energy dense, cost less, and take less time to manufacture than lithium-ion batteries. Over the last year, we have been reporting on Tesla's battery research partner Jeff Dahn and his team at the Dow House University, unveiling the impressive results of tests on a new battery cell that could last over 1 million miles in an electric vehicle. The team has been working for Tesla to improve energy density and longevity of battery cells while reducing costs. But Dahn, who is also a pioneer of Li-ion battery technology, and his team have also been working on next-generation battery technology, beyond improving on current technology. Last year, we reported on the team patenting an anode-free lithium metal cell for Tesla that they suggested could be the next big thing in battery tech instead of solid-state batteries. They are still working on the new cells as evidenced by a new patent application in Dahn's team for Tesla's Canadian research group. Electrolytes with lithium diluphoroxide bilabrate and lithium telephenolphonate salts for lithium metal and anode-free battery cells. Tesla lithium metal and anode-free battery patent, which will unveil the secrets behind Tesla's new technology. Tesla's undercover research in Li metal. While Elon Musk is knowledgeable about the ins and outs of batteries, he certainly doesn't have time to conduct battery experiments all day. As a result, Musk has formed a Tesla battery research team that is spearheading the progress in Tesla's new battery. This team is led by Jeff Dahn, who is one of the pioneering developers of the original lithium-ion battery. Jeff Dahn has recently been working on the next-generation battery technology that he expects will eventually overtake lithium-ion batteries as the most practical cell composition. While there has been plenty of hype around solid-state batteries, Jeff Dahn believes that the future of batteries is going to be a completely different battery cell, lithium metal and anode-free battery. Just to clarify some confusion, lithium metal and anode-free are not two different batteries, rather this is one type of battery named lithium metal and anode-free battery. This technology has been revealed in Tesla's new battery patent, which goes over Jeff Dahn and his team experiment with the battery. The current state of Li metal anode-free battery. Many researchers have previously attempted to manufacture lithium metal and anode-free batteries, however there has always been a certain shortcomings. Tesla explains these hurdles in lithium metal patents, stating the challenges with lithium metal and anode-free lithium batteries have prevented their widespread adoption. For instance, developing electrode composition that allows for commercially acceptable cycling performance of lithium metal and anode-free lithium batteries is critical to gain adoption of such battery systems. Essentially, what Jeff Dahn and his team are saying here is why lithium metal and anode-free batteries have plenty of benefits, the current lithium metal batteries are not able to have a high enough lifetime for commercial use. This is important because lithium-ion batteries can withstand hundreds of thousands of cycles. Jeff wrote, rechargeable batteries are an integral component of energy storage systems for electric vehicles and for grid storage, for example for backup power during a power outage and as part of a microgrid and so forth. Some such rechargeable battery systems include lithium metal and anode-free lithium batteries. Lithium metal and anode-free lithium batteries have certain advantages over traditional lithium-ion batteries, as they are more energy dense. Anode-free cells are also less expensive and easier to assemble due to their lack of anode coating. However, challenges with lithium metal and anode-free lithium batteries have prevented their widespread adoption. Improving certain characteristics of lithium metal and anode-free battery systems will allow for more widespread use of such systems. For instance, developing electrolyte compositions that allow for commercially adapting cycling performance of lithium metal and anode-free lithium batteries is critical to gaining adoption of such battery systems. Until the present disclosure, the general consensus in the industry is that an electrolyte with lithium diluphoroxide FOB salt alone best increases the capacity retention of lithium metal and anode-free lithium cells. The current lithium metal balancers are not even able to last 100 few cycles. While previous research has failed, Jeff Dahn believes he has found the solution. Dahn and his team stated that until present disclosure, the general consensus in the industry is that an electrolyte with lithium diphosphorate salt alone increases the capacity retention of lithium metal and anode-free lithium cells. By testing conventional tactics, Jeff Dahn was able to beat the general consensus in the battery industry. By using a new electrolyte, don't seem able to create systems that excited improved capacity capacity retention, this battery is more energy dense, is less expensive, and is easier to assemble due to its lack of old coating. While Jeff Dahn hasn't released any numbers on the energy density, recent tests done by Tesla on the lithium and anode-free technology were able to achieve an energy density of 2,600 watt-hour per kilogram. After this energy density is converted to driving range, this would equal to roughly 3,650 miles of a range. A battery with an energy density this high would not revolutionize automobiles, but practically every other device in the world. Dahn's current status with Li metal batteries. Now, while this technology is exciting, the truth is that it is still in development. Jeff Dahn's experiment were only able to get the battery to last roughly 75 cycles, which is far less than the range lithium-ion batteries are able to achieve. To put this into perspective, Jeff Dahn's tests with lithium-ion batteries were able to push the battery to 6,000 cycles, whereas his tests with lithium metals were only able to push the battery 275 cycles. While this may seem discouraging, keep in mind that if Dahn's battery is able to achieve a range of 3,650 miles, this would mean that the battery would still have a lifetime of close to 2,750,000 miles. Now, 250,000 miles may not seem like much in hindsight, but it's actually a sign of much more to come. At Tesla, metal battery technology still continues to improve. With Dahn's research, lithium metal and anode-free technologies will eventually take over lithium batteries. This would allow for more profits with vehicle-to-grid technology and robot taxis, ultimately allowing Tesla owners make boatloads full of money with that. On top of it, a range as high as 3,000 to 4,000 miles would mean that electric vehicle owners may only have to change vehicles once every few months, along with other electrical devices including laptops, cell phones, and watch would only need to be charged once every week.